Hi, D. Dykstra here, math guy, ready for you to do some optimization problems today. So, we're calculus, it's optimization, the problems we all like to love and do, and I have another video here for us for optimization problems. Let's review some of the strategies that we have from before, and that is one, in most cases we want to read through it and then draw a picture. Alright, so let me see if I can scoot this over a little bit for you. That way we don't have to have so much angle. Yeah, there we go. Identify key information. What things are in the write-up that they gave us that would help us solve the problem easier? Do we have a shape? What are we maximizing or minimizing? Do we have two equations? A lot of times these problems have two equations. Do they give us anything to eliminate a variable and utilize two equations to make one differentiable equation? Then, once we do that, can we substitute in one of the equations back into an equation where we're going to maximize or minimize it? Take the first derivative, find critical values, and solve for missing variables. All right, let's see. So, here we have a question. It says, which points of the graph of y equal 4 minus x squared are closest to the point 0, 2? All right, so 4 minus x squared is a parabola. It's pointing down. It's raised up 4 units. Negative parabola, which goes through the points negative 2 and 2. It's the basic parabola that we have. And what it's asking is, along this curve, which points are the closest, right? Is it over here? Is that closer to this point 0, 2? And so 0, 2. Maybe not be able to see it very well there, but it's right here in the middle. Okay? So we want to know, is the point over this way, or is it up here? Where is that point exactly? And since it's a parabola, what do we know about parabolas? They are, starts with an S, symmetrical. That's right. So they're symmetrical, which means if I find a point on one side, it will be equidistant as the other side. So in this case, we might find one critical value, and if we end up getting something squared, it's going to be on the right or the left of our line of symmetry, which in this case happens to be x equals 0. So we want to find something close, so that means we are a max or a min. That's right, we're looking for a minimum, which means the second derivative should be a positive number in that case, so we'll have a minimum value there. All right. Well, what I start to think of as we start to look at this, the shape, well, we have the shape. Are we maximizing or minimizing? We're minimizing. Two equations. We have one equation that they gave us, right? That's the equation of the curve. And now the next equation we have to think about is, you might see it over my shoulder, the distance formula. Now, why distance? Well, that's because it's asking for the points that are the closest. So let's scoot this over here now a little bit, as we can see. So now, in this case, what we're looking to find is, since we are working with a point being close, we have to think of distance. Okay? Think of distance. Now, distance is the square root of x2 minus x1 squared plus y2 minus 1. That's the basic distance formula. Now, if we were to take the derivative of that, then what we would have is y's and x's all involved here. We don't want y's and x's all involved, so that's where the need for the secondary equation comes in. So we have this equation right behind me, right there, and then we have this. So what we're going to do is we're going to use part of the values that we have, given the x and y point that they gave us, 0, 2, and we're going to use our function of y equals 4 minus x squared. So for our x's, that's pretty simplistic. We just x minus 0 squared plus, now instead of being y2, well, y2 would be on the curve somewhere, right? Right, over here. But we don't know what that y2 is, so what we're going to do is we're just going to call it the function, 4 minus x squared. So we get 4 minus x squared minus 2, because that we do know is the second y. It's over here. It's the y value of 2 right there. So, but that ends up getting squared. Now, don't forget, that distance is equal to, well, x squared plus, now what we had to do here is you had to take 4 minus 2 is 2. You get 2 minus x squared, and then because that's squared, that's a binomial square, so you have to work on that, expand it so that you get a polynomial out of it, a trinomial. Well, that trinomial, after you subtract 2, becomes 4 minus 4x squared plus x to the 4th. I challenge you to put 2 minus x squared in parentheses and square it, and you will get that. All right. Now we have to combine like terms. So I have a 1x squared and a negative 4x squared, so and positive x to the 4th. So I get x to the 4th minus 3x squared plus 4. All right. Now, because each value that we're getting will be square rooted, they will both be small values. All right. So we don't necessarily have to take the square root of this function, and because that would then create chain rule, and inside, outside, we'd have a lot of work to do there. Instead, what we can do is just find out what the x value is underneath, and we can go for it in that direction. So we only need the derivative of the inside, so we'll take derivative of the inside, 4x cubed minus 6x. That is equal, now we set that equal to 0, right? If you recall from the rules, we take the first derivative, set it equal to 0, and find our x values. So we set it equal to 0. We're going to factor out a 2x. That leaves us 2x squared minus 3 equals 0. We get 2x equals 0, so we get one value as x equals 0. And then we get values of 2x squared minus 3. And we get work down here, and we get x is equal to plus or minus square root of 3, 2. All right? So, again, x is equal to positive or negative, right there, square root of 3 over 2. All right, now, let's keep going because we have some more things to look at. We know our x values, and we have to figure out, are they maximum or minimum? Well, we take the second derivative, and we find that since we're dealing with an x squared, so the second derivative is 12x squared minus 6. Now, if we put in a 0 here, then that would be 0. Would be negative 6. We'd be dealing with a maximum. So we don't want x is 0. So what we can do is we plug in our plus and minus root 3 over 2. And if we do that, since it's squared, both values will create a positive result, which will be a minimum, right? Hence, negative root 3 over 2, and that should be the square root of 3, excuse me. All square rooted, excuse me. All square rooted. Square root of 3, square root of negative yields a 5/2. And this is a square root of 3 over 2, all inclusive. That will reduce, also give us a 5/2. And why do those two give us the same y value? Well, that's because it's a parabola. They're symmetrical. So if whatever I have on the left and whatever I have on the right, each of those will give me the same y value as long as they're the same x. And they are the same x. It's just one's a negative and one's a positive. So they're equidistant from the line of symmetry. There are the 2 points closest to this. So these are the 2 points. Negative square root of 3 over 2, all inclusive of the square root, comma 5/2, and positive square root of 3 over 2, all inclusive, and comma 5/2. All right, and that is another great day and optimization with D. Dykstra, your math coach. We'll talk to you soon. Have a great day. Keep it mathy. All right, bye.